Let us consider another example. Suppose following equation. Number 1, x plus y plus z is equal to 6. X plus 2z is equal to 7. It is 2. Is equal to 7. And 3x plus y plus z is equal to 12. 3x plus y plus z is equal to 2. You may write these three equations in this manner also. 1x plus 1y plus 1z is equal to 6. Similarly, 1x plus 0y plus 2z is equal to 7, and 3x plus 1y plus 1z is equal to 12. Then you will get b is equal to like this: 1 1 3 1 1 3 1 0 1 and 1 2 1 1. You can expand this determinant and the value of b will be obtained to be 4. Number 2, b1 would be like this. In place of 1 1 3 6 7 and 12, so this column 6 7 12 we replace the first column 6 7 12 1 0 1 1 2, and after expansion you will get b1 is equal to 12. Similarly, b2 would be like this. b2 is equal to 1 1 3 1 1 3. The second column will be replaced by 6 7 and 12. So 6 7 and 12, and the third column will be remain unchanged: 1 1. After expansion it will give you b2 is equal to 4, and b3 is equal to like this. b3 is equal to 1 1 3 1 0 1 and 6 7 12, and this is equal to 8. Okay. Now we have the solutions like this. Hence x is equal to d1 by d is equal to d1 by d, and d1 by d is equal to 12 by 4 is equal to 3, and y is equal to d2 by d, and that is equal to 4 by 4 is equal to 1, and z is equal to d3 by d, and d3 by d is equal to 8 by 4, that is equal to 2. So x is equal to 3, y is equal to 1, and z is equal to 2. These are the solutions. So this one, and this one. These are the values of x, y, and z. So this is a very simple example for your convenience, and it has been assumed that all the students studying in class 12, particularly in science, are acquainted with the primary knowledge of determinants. If you find any difficulty to understand about the expansion of the determinant, you may again respond, and if required and requested by the students, I shall give another video regarding the rules of expansion of a determinant. And for your convenience, I am giving another problem with solution, and you must consult this for your further knowledge. Let us consider a plus b plus c is equal to 8. Four a plus 2b plus c is equal to 11. 9a minus 3b plus c is equal to 6. Now it is very easy to determine the determinants. Here d is equal to 1, 4, 9. 1, 2 minus 3. And 1, 1, 1. This is d. Okay. And after expansion, you will get this is equal to minus 20. Then d1 is equal to the first one. This column will be replaced by 8, 11, and 6. So this is equal to 8, 11, and 6, 1, 2, minus 3, 1, 1, 1. Okay. After expansion, you will get d1 is equal to minus 10. Similarly, d2 is equal to, in case of d2, the second column is replaced by this So this is 1, 4 and 9. The second column will be replaced by 8, 11 and 6. 8, 11 and 6. And third column will be remain unchanged. And this will give you D2 is equal to minus 30. And D3 is equal to, once again, 149, 149, 1, 2 minus 3, 1, 2 minus 3, and the third column will be replaced by 8, 11 and 6. So this is 8, 11 and 6. Now D3 will give you, after expansion, D3 is equal to minus 120. Minus 120. Now we know x is equal to d1 by d. X is equal to d1 by d. d1 is equal to minus 10 and d is equal to minus 20. So minus 10 by minus 20 is equal to half. Similarly, y is equal to d2 by d, and d2 is equal to minus 30 and d is equal to minus 20 is equal to 1.5, and z is equal to d3 by d, and d3 by d is equal to minus 120 divided by minus 20 is equal to 6. So these are the results. Half, 1.5 and 6. The values of x, y and z. Now I shall give you a hint about the application of this rule in case of electrical circuit. Okay. Now we are drawing an electrical circuit like this. Suppose there is a circuit. This is the resistance. This is the cell. This is another resistance. Another resistance. Another cell, but polarity has been changed. Look here. This is negative. This is positive. This is negative. This is positive. And there is another resistance. And there is another cell. This end is positive. This is end negative. Again, there is another mesh. The part of the circuit is known as mesh. M-E-S-H. Resistance and resistance. And there is another cell. This is positive. This is negative. So in this complicated circuit, there are 1, 2, 3, 4, 5, 6 resistances. So this is R1. This is R1 resistance. This is R2. Suppose this is R3. This is R4. This is R5. And this is R6. There are total 6 resistances. And this cell is U1 of EMF. It has EMF E2. It has EMF E3. And it has EMF E4. So in this circuit, this is a complicated circuit. So long you have studied very simple circuits in class 10, and in case of class 12 you have to acquainted with the complicated circuits. So in this circuit there are in total 6 resistances and 4 cells, and the values of R1, R2, R3, E1, E2, E3, etc. will determine the amount of current passing through different meshes. Mesh means a loop. Loop means, suppose you are starting from this point and again coming to this point. This means a loop. So this loop number 1, the current flowing through this is equal to I1. There is another loop. Loop number 2, the current flowing here I2, and then another loop. Current flowing through this is equal to I3. Suppose. So the values of R1, R2, etc. These 6 values and these 4 values are known values. But I1, I2 and I3 are unknown values. Now your duty is to frame 3 sets of equations, independent equations, considering this total circuit. And if you can frame these equations and apply the rule given by Cramer, that means Cramer's rule, judiciously and efficiently, then you will find out the value of current in different meshes. So this was the aim of my class, to make you acquainted with the Cramer's rule. And in the next class, I shall go through the original rule of physics, that means Kirchhoff's law. And once again, you have to visit another class to be acquainted with the application of Cramer's rule in case of electrical circuits. Thank you for watching this video.